sure if you guys can see this. So I'm just going to zoom in at each graph. So this is the linear, right? And you see that your r squared is 0.9778. And then we see the quadratic equation. See it's a good fit. We see the r squared is equal to 1. And then the exponential, and it's also a good fit, and the r squared is 0.9981. Okay? Out of these three, if you are to eliminate one, which one would you eliminate right away? The linear. That's right. Why? Why would you eliminate the linear? That's the one where the r squared is the farthest away. And remember I told you, the closer the r squared it is to 1, the better it is. Right? So if I'm looking at the other two have a much better r squared value. Right? They're not much better. Like, I mean, this is like 97.7, this is 99.8, and this is a 1. Right? So right away, if we're going to eliminate one process of elimination, we're going to eliminate the linear. It's not a very good fit. Okay? Now, if I'm looking at the other two, which one would you pick and why? And why? The r squared is 1, but then this is also, if I'm going to round it, it's going to be 1. So, yes, this is a 100% perfect fit. This is like a 99.8. But then think about that water bottle, right? And think about the difference between exponential and quadratic, right? So if I have this water bottle here, and I put a hole right here, right? You're going to see that the water is going to start decreasing, right? Because the water is coming out of the bottle. But then at the end, you're going to have no more water pouring out. But you're going to still have some water in that, in the bottle, right? But the thing is, that water is not going to come up, right? So the water is not going to, whatever is in the left in the bottle is not going to come out because they're below the hole, okay? It's not going to go up either, unless you fill it, right? Okay, so in this case, we don't want something that's going to keep going down and then flattening out, right? It's going to reach a minimum and then it's going to stop. So that's why we're going to pick the r squared, okay? Remember that with quadratic, that's why we're going to pick quadratic. Remember with quadratic, you can also come back up, right? That's not the case that we have. In this case, we're going to reach the minimum and then that's it, right? We're going to stop. It's going to stop right there. My graph is going to stop. My timer is going to stop. My whole equation is going to stop, okay? With the exponential, technically speaking, you should flatten out. You should be decreasing little by little by little by little every single second, right? Which that's not going to happen anymore for us, okay? So that's why we picked the quadratic. It is a much better fit, right? But also it does make a little bit more sense than using exponential, because exponential, you're going to see that it's going to keep decreasing with time. This, you're going to reach the minimum, and then it's not going to decrease anymore, okay? So let's write down some explanation here. So we know that the linear model is the worst fit. It has the lowest r squared. The quadratic and exponential model are closer So if I'm going to explain this, water below the hole cannot drain out of the bottom. So the best model is one which will stop decreasing at some point. And we said that the exponential is going to keep decreasing.
Thank you.
Right? We said that the exponential is going to keep decreasing, so that's why the quadratic is the one that's going to reach a minimum and stop decreasing. So that's why we're going to pick the quadratic. Okay? And on top of that, it has a much better R squared. Not much better, but a better R squared. Now, let's assume that the R squared for the quadratic was worse than the exponential. Would I still pick quadratic? Let's say the R squared for quadratic was worse than the exponential. So let's say the R squared for quadratic was 96. Would I still pick quadratic?
Yeah.
No? Because the exponential has a better fit. So I'm going to have to pick the exponential. Right? So R squared should be the one that decides. Okay? The better the R squared, the better it is. But because in this case, the R squared are too close, then I can choose, depending on the scenario. Okay? But if the R squared are off, then I have to pick the one with a better R squared. Does that make sense to you?
It's where is the line between it's close enough or it's far? I think 0.98 is too far now.
It is far. So, but this one is 99.8. 99.8 rounds up to 1,
Okay, so
right?
it's common.
98 does not round up to 1, right? But 99.8 is a good close to 1, right? So think about it this way. If I give you a test that has 99.8, what does that mean? Why did I put the 0.8? I can't give you 99.8. I should be giving you 100, right? It's the same thing. But if you have 98 and 100, there's 2% difference between them. Okay? Are we okay with that? Okay. Yep. What did I say yesterday? What did we have to do in the calculator? Yes. The E button. Yes. Why do you get the equation? Probably your points are over.
No, it's same points. It's here. Change. Anyway, now we find seven.
Did you check, make sure that these points are exactly the same? What's your rounding